Now that we have these whole new set of properties, we can solve a whole new set of problems. For example, if cosine of x is equal to 0.3, find the exact value of cosine 2x. Well, let's pull out the properties we have for double angles, since we're asked for cosine 2x. And we're trying to solve for cosine 2x. And it turns out we have three different possibilities for the cosine of 2x. We have cosine squared a minus sine squared a, or 2 cosine squared a minus 1, or 1 minus 2 sine squared a. Now, to come up with this value for cosine 2x, and given the fact that we only have information about cosine x, I'm going to choose this second representation, since it's the only one that uses cosine of an angle and only cosine of an angle. So we take that representation and we rewrite cosine of 2x as 2 cosine squared x minus 1. Well, we know what cosine x is, according to the question. So the cosine of 2x is going to be 2 times 0.3 squared minus 1, which means that's going to be 2 times 0.09 minus 1, or 0.18 minus 1, or negative 0.82. So our answer is negative 0.82. Let's look at another possible question. Let's write an equation expressing the cosine of 10x in terms of sine 5x. So I have 10x and 5x. And when I say write an equation expressing cosine 10x in terms of sine 5x, that means that I'm going to rewrite the expression cosine 10x with a new expression that only has constants and the expression sine 5x in my answer. So I'm going to pull out my double angle properties, since 10x is twice 5x. I'm going to look through my properties here for an expression for cosine of a double angle in terms of the sine of the single angle. And if I look closely, I will see that my third expression for the cosine of a double angle has the sine of the angle as part of its equivalent expression. So the cosine of 10x is going to be equal to 1 minus 2 times the sine squared of 5x. I've written the cosine of 10x with a new expression that only has constants and the sine of 5x as the trig function. Now let's look at some additional problems, including some that have half-angle issues. So we'll start with the information that cosine of a equals 15 over 17, and a is in the open interval 270 degrees to 360 degrees. Now if I drew our Cartesian coordinate system, 270 to 360 is down here in the fourth quadrant. And we're going to try to find the exact value of the cosine of 1/2 a. 270 to 360 is down here in the fourth quadrant. And we're going to try and find the exact value of cosine 1/2 a. So if our original angle is between 270 degrees and 360 degrees, then half that angle will be between 135 degrees and 180 degrees. And that would put us in the second quadrant. And we'll keep that in mind as we continue to solve this problem. That tells us that the cosine is negative. Now let's pull out our half-angle arguments. We're trying to solve for the cosine of 1/2 a, right here. So we're going to use the formula, and that will tell us that the cosine of 1/2 a in this case is plus or minus the square root of 1/2 times 1 plus the cosine of a, where the cosine of a is 15/17, which we can simplify to plus or minus the square root of 1/2 times 32/17, because 1 is 17/17, which then becomes plus or minus the square root of 16/17, because we can cancel out here. And then we have to choose the plus or minus. But by our logic earlier, we know that the cosine is negative. So our final answer will be negative square root of 16/17. Now let's find the exact value of the cosine of 2a. So we're not going to need these half-angle arguments anymore. Let's pull out our double angle arguments. And to find the exact value of cosine 2a, we're going to need a formula that uses the value of cosine a, which would be our formula right here. So cosine 2a is going to be equal to 2 times the cosine squared, so 15/17 squared minus 1. And if we do the math, we will find out that our answer is equal to 161/289. So let's do a quick recap. What are the equivalent expressions for the products and squares of cosine and sine? Well, the product of a sine and a cosine can be rewritten as 1/2 the sine of 2x. Cosine squared can be rewritten as 1/2 plus 1/2 cosine 2x. And sine squared x can be rewritten as 1/2 minus 1/2 cosine 2x. What are the double argument properties for sine, cosine, and tangent? Well, the sine of 2a can be rewritten as 2 sine a cosine a. The cosine of 2a has 3 different representations: cosine squared a minus sine squared a, 2 cosine squared a minus 1, and 1 minus sine squared a, which are all related through the Pythagorean properties. And the tangent of 2a can be rewritten as 2 tangent a over 1 minus tangent squared a. What are the half-argument properties for sine, cosine, and tangent? Well, those half-argument properties, for the sine of 1/2 a, that's equal to plus or minus the square root of 1/2 times the quantity 1 minus cosine a. The cosine of 1/2 a is equal to plus or minus the square root of 1/2 times the quantity 1 plus cosine a. And finally, the tangent of 1/2 a has 3 representations: plus or minus the square root of 1 minus cosine a over 1 plus cosine a, or 1 minus cosine a over sine a, or sine a over 1 plus cosine a. And as we've seen, the properties that have multiple representations are the double argument properties for cosine and the half argument properties for tangent.